Hi everyone, I hope you're okay. This is video number 4, guys. That means I'm doing question 4 from the November 2023 Physical Science Paper 1. If this is the first video you come across, please note that there are 3 videos before this one whereby I've answered all the first 3 questions. Let's just get into this one. But guys, please don't forget to subscribe. You subscribing will help us to grow the channel and probably will reach many learners as possibly can as possible. Okay, we are being told that a wooden trolley of mass 2.7 kilograms moves horizontally to the left with a constant speed of 3 meters per second. A bullet of mass 0.3 kilograms is fired horizontally from the left towards the trolley. See diagram 1. We are dealing with the conservation of momentum in this question, guys. Please note that momentum is a vector quantity, and whenever you deal with the vector quantities, you must always assign your direction. Choose which direction is positive. In this case, the only movement that's happening is horizontal movement. So it's either I say anything that moves towards the right is positive, or anything that moves towards the left is positive. So for now, let's choose anything that moves towards the right or east as positive. Together, this thing simply means that anything that goes to the left will be negative. For example, in this case, I have a constant speed of 3 meters per second, and this wooden trolley is moving to the left, which simply means that I have negative 3 meters per second. Okay, and then we are told that the bullet strikes a trolley and comes to rest inside the trolley. The average net force exerted by the trolley on the bullet is 591 newtons. The bullet trolley combination now moves to the right. Okay, and then we are told that we must ignore the effects of frictional and rotational effects. The first question, we are being asked to write down the magnitude and direction of the average net force that the bullet exerts on the trolley. Okay, the bullet will kind of influence the trolley to move towards the right. So the remember that, guys, whenever two things collide, we will always use or apply the principle of Newton's third law, which simply says that if body A exerts a force on body B will exert an equal but opposite force. So yes, the force is equal. I have 591 newtons together, but the direction is not the same. We are being asked to write down the magnitude and direction of the average net force that the bullet exerts on the trolley. So the bullet will kind of force the trolley to move towards the right? So I'll simply say 591 newtons to the right, or if you want to, you can simply say in the eastern direction. Okay, and then now we are being asked to calculate the magnitude of the velocity with which the bullet strikes the trolley. There's only one force that the bullet has, because we were told to ignore the effects of friction and the effects of rotation, right? So the force that will be exerted on the bullet is from the trolley. So the trolley will kind of push the bullet towards the left. Are you together? So I can simply use my equation that says F net delta T is equal to delta P. Are you together? Where delta P represents the change in momentum. F net delta T, this will be M VF minus VI. Okay, remember that I said that the trolley will try to push the bullet towards the western direction. So the bullet will experience a force of negative 591 newtons, and the time it takes for the bullet to exert this force is 0.2 seconds, right? The mass of the bullet is 0.03. The final velocity is 0. Why am I saying that? Because the bullet will eventually come to a stop. And then I want to know the initial velocity of the bullet before the collision. So I'll simply have negative 591 multiplied by 0.02. How? Negative 591 by 0.02. I'll simply get negative 11.82. Then on the right hand side, I'll simply get negative 0.03 VI. When I divide both sides by negative 0.03, I'll simply get my VI to be 394 meters per second, like that, né? If they didn't say calculate the magnitude, if this word was not there, they said to me calculate the velocity with which the bullet strikes the troll, I would that means I would have assigned both the magnitude and the direction. But now I was told that I must find the magnitude. So if whenever I write the velocity is just 394, there's nothing wrong. I did. But if they wanted the direction, I would say to the right or east. But in this case, direction does not matter. Okay. And then 4.3, we are being asked to state the principle of conservation of linear momentum in weights. It says that in an isolated system, the total linear momentum is conserved, which simply means in the absence of non-conservative forces, the total linear momentum is conserved. Okay, then 4.4, we are being asked to calculate the magnitude of the velocity of the bullet trolley combination after collision. So since momentum is conserved, it simply means that the sum of the momentas before collision is equal to the sum of the momentas after collision. Right, together. So it will be mass of object A multiplied by the velocity of object B plus the mass of object B multiplied by the velocity of object B. After collision, they become one unit, right? So I'll simply have the mass of A plus the mass of B multiplied by the velocity of the bullet trolley combination. So if I take my bullet as my object A, and then this will be object B, it simply means that my mass for this one will be 0.03, and then the velocity is just 394, plus I have 2.7, and the velocity is negative 3, and then I'll have 0.03 plus 2.7 multiplied by the final velocity. So this is 0.03 multiplied by 394 plus 2.7 multiplied by negative 3. This will give me 3.72 is equal to 2.73 VF. Whenever I divide both sides by 2.73, I'll get my velocity to be 2.73. I'll get my velocity to be 1.36 meters per second to the right, since I found my velocity to be positive. So the final solution there, the velocity is just 1.36 meters per second. Are you together? But if I took the western or the or any movement to the left as positive? Yes, I would find the same answers, but now the only difference would be the signs. Are you together? Okay. For the first one, for the first one, the answer will be the same, and then 4.3, the principle does not change. Yeah. But now let's calculate by using. Let's only do question 4.2 and 4.4. Né? Remember that right now we are taking the western direction as positive. The west or left direction as positive, right? So in this case, remember that, guys, the bullet will exert a force from the trolley that will try to push it to the left. Are you together? So remember that I'll say F net multiplied by delta T is equal to the change in momentum, right? F net delta T is equal to M VF minus VI. So my force, please note that, guys, I am choosing any direction to the left as positive, right? So the bullet will experience a force that will try to push it towards the left. So I'll have positive 591 multiplied by the time it takes for the bullet to experience this force, which is 0.02, and then the mass of my bullet is 0.03. It will eventually come to a stop after 0.02 seconds. So whenever anything comes to a stop, its velocity will become 0. I don't know my initial velocity. So I'll simply have 591 multiplied by 0.02. This will give me 11.82 is equal to negative 0.03 multiplied by VI. So I'll divide both sides by negative 0.03. And therefore my velocity will be negative 394 meters per second. The negative simply means that my bullet was moving in the negative direction, right? In this case, which direction is negative? The eastern direction is the one which is negative. But it was shown very another pair with the bullet was moving towards the eastern direction. So the magnitude of the velocity will be the same as this one. And then 4.4, what we need to do for 4.4, remember that, guys, we're told that there are no effects of friction and we must ignore effects of friction and rotational forces, right? So in this case, guys, we have a closed system because we don't have non-conservative forces. So we can simply conclude that the sum of the momentars before collision is equal to the sum of the momentars after collision, right? So it will be just the mass of object A multiplied by the velocity of object A plus the mass of object B multiplied by the velocity of object B is equal to the sum of the masses. Why? Because they now move as one system, right? I only need to find the velocity of their combination. The mass is 0.03, right? And the velocity is 394. But remember that the bullet before the collision was moving towards the right. So I have a negative here. Plus I have 2.7 as the mass of the trolley, and then 3 meters per second. The trolley was moving towards the left, and I did state that the left now is positive. So it simply means that I'll have a positive 3 there. So this is just 0.03 plus 2.7 multiplied by VF. This will give me 0.03 multiplied by negative 394 plus 2.7 multiplied by 3. This will give me negative 3.72, and then on the other side I'll have 2.73 VF. So I'll divide both sides by 2.73, and then my VF will be negative 1.36 meters per second, right? The negative simply states that the bullet and trolley system were moving towards the right, towards the negative direction, because right now we've chosen the western direction to be positive, which simply means the eastern directive will be negative. Are you together? So it's important, guys, that whenever you are dealing with the vector quantities, please do state your direction. Thank you, guys. If you like the video, please don't be afraid to click the like button, share as much as you can. Just help us, guys, to grow the channel, and maybe we'll reach a lot of learners as soon as possible before they write their final examination. Thank you very much for your time, guys.